have the same number of neutrons. Let's talk about hydrogen, since that's a little bit easier. Hydrogen typically is just a proton, and if it's neutral, with an electron zipping around. But a hydrogen atom could have a neutron in there. It doesn't change the number of protons, so you could have a neutron in there. So you have two things in the nucleus, or two nucleons. This has a name, deuterium. You can also have a proton in the middle, and you can have two neutrons. Anyone know the name? Tritium. Now, there is an optimum number of protons and neutrons that go into the nucleus. As you add more neutrons into it or have fewer neutrons into it, it becomes less stable. When you're talking about an atom being unstable, it will break apart. This is known as decay. Usually it gives off some radioactive piece, radioactive decay. Water, H2O. Regular water has just the proton from the hydrogen. It's got two protons there, and then you've got the oxygen over here, and it's sharing some electrons. If instead I use deuterium, this is what is instead of that. So I have D2O. This is heavy water. Heavy water is just that you've got more in the nucleus than typical. Now, if you also notice over here, you got the various different rows, so what they're calling periods, the various different rows, that is indicating the number of shells there are. So every time you go to a new row, you go to a noticeably larger radius. As you come this way, you still have the same number of rows. You're basically increasing mass as you come this way without increasing the radius significantly. So you've got one proton over there, one electron buzzing around. Stick another proton into the middle, you got a helium atom, and the helium atom is not significantly bigger than the hydrogen. When you jump to lithium, you are now at a noticeable level. Now the row also determines the number of electrons in the outer shell. These are the electrons in the outer shell, or the electrons that can come out and play. Basically, when you're working with an atom here, the electrons that are farthest out are the ones that are the easiest to interact. So that's why you'll find anything in the same row here will have similar chemical properties. And the last remaining thought, say my helium atom here, I have a proton here and a proton here. They're like charges. So what do they naturally want to do? Why don't they?
Stuck inside the nucleus.
It's not, the nucleus is not literally, like a bag that's stuck inside. It hasn't been kidnapped.
It's got the electrons going around. I don't know.
Sort of like proton wrangling.
Yeah.
Except the electrons like the protons, they're trying to pull the electrons in. You got these two protons that hate each other, want to get away. You got these electrons buzzing around the outside that want to pull in, want to pull the protons towards them, yet the protons don't leave. Thus the neutrons. There's another force involved here that's keeping the protons and the neutrons together. That force is a pretty rather strong force to keep them together, because the protons hate each other, but it somehow keeps them together. So physicists went to the thesaurus to come up with a really clever name for it. It's called the strong force. Now, sometimes the atoms will break apart, that there's another force involved that will separate them. That force that is gonna separate them is not, it's not as strong as this is. What name do you think they came up with?
Stronger force.
It's not as strong,
Oh.
weak force. And then weak force is actually not the weakest of the forces, gravitational force is the weakest. But, and then there's an attraction here between these two, and that is known as an electric force. And the big question in physics, one of the big questions is, yeah, to us, they look like different forces, but are they really that different? And this is known as, if you ever hear the reference to GUT, or grand unified theory, or unified field theory, it's that idea of trying to bring it all together and show that they're all aspects of the same thing. In a similar vein to liquid water, ice, and steam are all the same basic composition. It's just different energy levels. Similar idea here. Anyway, have a safe week.